square there are 5 small squares, so will have 0.5 millivolt. In the horizontal axis, one small square represents 0.04 seconds. Okay, so the one large square will represent 0.04 into 5, यानी कि 0.2 seconds. ठीक है, and two large squares will represent 0.5 plus 0.5 means 1 millivolt. So these are the grid lines on the standard ECG paper, and this we need to know to calculate the amplitude of the signal and also the duration of the signal. So what we like to see in the ECG, we like to see the rate, we like to see regularity, we like to see the P-wave morphology, then DR interval, reverse complex morphology, ST segment morphology, P-wave, U-wave, QTC interval. As I mentioned, QT interval is very important because patient can have toxicity points and then in case of prolonged QT, then rhythm of the signals. So this all needs to be interpreted. In different ways, we have to see general contours, duration, positive and negative amplitude, access in the frontal and transverse planes. So this all we need to calculate. So how the rate is calculated? The rate is calculated either dividing 300 by number of large squares between the two reverse complexes. Suppose we see the two RR complexes, and between two RR we have 1, 2, 3 and 4 large squares. So the rate will be, the heart rate will be 300 divided by 4 or 75 beats per minute. Suppose like this we can calculate. Suppose there are only 3 squares between the two RR complexes. There are 3 squares, then rate will be 300 divided by 3, यानी कि rate will be 100. ठीक है, and if we are counting the small squares, then we have to divide it by 1500. ठीक है, so 1500, suppose there are gap between the two RR complexes is 10 small squares, then rate will be 1500 divided by 10 is equal to 150. ठीक है, so this is how the cardiac rate is calculated. So how we define the tachycardia and bradycardia? If there is gap between the two RR complexes up to 5, then it is normal. And if it is gap is between two RR complexes is 3, then also it is normal. So if the gap between RR interval is 3 large squares or 5 large squares or between it, then it is normal heart rate. So the heart rate at the 3 squares will be 100 and 5 squares will be 60. So between 60 to 100 is normal. Anything which, if the duration between two RR complexes increases to 6 large squares, 7 large squares, then it is bradycardia. So heart rate is 50 at 6 squares, then it down goes further with the 7 large squares. Likewise, if the number of large squares decreases up to 2, up to 1, then heart rate rises. So this is how the relation between the RR interval and the heart rate. So these ECG paper has some 3-second markings. Okay, so between this marking and this marking it is 3 seconds, and between this and this marking it is 3 seconds. So the total is around 6 seconds. So suppose patient has atrial fibrillation, means patient rhythm is not regular, then what we do? We count the number of QRS complexes in 6 seconds and then multiply it by 10. So here to here is 6 seconds. We now will count number of QRS complexes between 6 seconds and then we multiply it by 10 because 6 into 10 is 60 seconds. So we can calculate the heart rate of the patient, average heart rate. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. There are 10 QRS complexes between 6 seconds. So if we multiply it by 10, then heart rate will come to 100. So this is how we calculate the heart rate in atrial fibrillation when rhythm is not regular, when RR interval varies with beat to beat. So this is a typical normal P wave and it is divided into 0.04 second intervals. This is P wave from the lead 2 and this one is the P wave from the lead V1. So initial component is from the right atrium, after that it is right atrium and left atrium, and later part is only because of left atrium. So initial part is because of right atrium and later part is because of the left atrium. These are the intervals we have already studied. What is the importance of all these intervals? So look at the morphology of the QRS complex. Lead V1, lead 1, lead 2, lead AVL, they have small Q waves. And this is normal. And V4 to V6 also have small Q waves. And this is normal because this is because of septal depolarization. So Q wave, if it is large and it is in the lead which usually doesn't have Q wave, then it is suggestive of old myocardial infarction. Otherwise, if it is narrow Q wave, it is small duration Q wave, then it can be normal also. So in lead 1 and 2, if the upper limit of the Q wave duration is 0.03 seconds. Lead 3, we should not have any, there is no upper limit. In lead AVR, there is no upper limit. Means in these two leads, Q wave can be any large. In V4, V5, V6, again there is upper limit of the Q wave, 0.02, 0.03, 0.03. And in lead V1 to V3, if there is any Q wave, then it is abnormal. Okay. So in lead 3 and AVR, any Q wave can be normal. In lead V1 to V3, any Q wave is abnormal. And between 1 and 2, AVL and AVR, V5 and V6, it is narrow Q wave of 0.03 second duration, and it is normal.
ये गंदा कप है, सुसु किया था ना तुमने इसमें?
So this is panoramic display of the precordial leads.
यहाँ नहीं, वहाँ
The initial complex is predominantly S wave, and then there is increase in the R wave and K wave. Then there is transition into V3. After V3, the QRS complex becomes predominantly positive. In V5, the amplitude is maximum. After that, in V6, amplitude again decreases. So this is the panoramic display of the precordial lead voltages. See, this is the morphology of the QRS complex. So we have divided into 0.04 second time intervals, and initially there is Q wave in lead 3.
मम्मी वाला फोन तो वहीं पे रखा है,
तुम
बात करके बाहर गई थी.
Positive wave. So this is how the QRS complexes look like in different leads, lead 1, lead 2, lead 3. From the beginning of the